For centuries, naval combat has adhered to a fundamental sequence. Vessels would first detect an adversary, then classify the threat, decide on an appropriate response, and finally, engage. This detect, classify, decide, engage cycle has been the bedrock of maritime warfare. It was a process inherently designed for human-centric decision-making, where time was often a critical, though finite, luxury. The survival of a ship and its crew frequently hinged on the efficiency and speed of this sequence. Today, this traditional paradigm is undergoing a quiet, yet profound transformation. The integration of high-energy laser weapons onto naval platforms is fundamentally altering how ships perceive and react to threats. These advanced lasers are no longer standalone systems, they are directly linked to a ship's primary sensor and radar networks. The once distinct stages of detection and reaction are now collapsing into a continuous, integrated action, demanding an entirely new approach to naval defense. The journey of naval laser systems began with early experimental programs. These initial efforts often involved standalone systems, typically bolted onto ships for testing and evaluation. They required dedicated operators and their own separate targeting sensors, operating somewhat independently of the ship's main combat architecture. While these early tests undeniably proved the potential of directed energy weapons, they also highlighted a critical weakness. Their independent operation introduced inherent delays, slowing down the overall decision-making and engagement process. The shift to integration marks the dawn of a new era for these weapons. Modern lasers are no longer isolated tools, they are deeply intertwined with the ship's operational ecosystem. They are directly tied into sophisticated radar systems, electro-optical sensors, and the overarching combat management systems. This deep integration allows for instantaneous data reception from a ship's primary sensors, eliminating previous data transfer bottlenecks. Crucially, these integrated lasers now utilize the very same tracking information that guides traditional missiles and guns. This unified data stream eradicates engagement delays, ensuring the weapon precisely knows where to look and fire the moment a threat is identified. The integration of laser weapons is no longer a theoretical concept, it is an operational reality. The U.S. Navy, for instance, has already deployed these systems on its destroyers. Their primary targets include unmanned aerial vehicles, small surface threats, and other low-cost targets that can overwhelm conventional defenses. This operational deployment fundamentally changes the economics of naval defense. A laser shot costs mere dollars, in stark contrast to the millions of dollars for interceptor missiles. This cost-effective neutralization capability makes defending against swarm attacks or persistent low-end threats economically viable. Integrated lasers offer a fundamental change in reaction time. A laser engagement is nearly instantaneous, limited only by the speed of light itself. The primary limitations shift from reaction speed to challenges such as power management and thermal control. A ship's radar detects a threat, its combat system decides on the optimal response, and the laser executes the engagement, all within mere seconds. This drastically compressed timeline offers an unparalleled defensive advantage against fast-moving or numerous targets. Furthermore, these systems provide greatly increased precision. Ship radars supply essential data on range, speed, and trajectory, offering a broad picture of the threat. Electro-optical sensors then refine this information, pinpointing the exact target position with extreme accuracy. The laser, guided by this fused data, maintains a stable beam on a precise point of the target. The objective often isn't complete destruction, but a mission kill, disabling the threat by blinding its sensors or overheating its critical components. This precision minimizes collateral damage and conserves energy for subsequent engagements. Beyond the tactical, integrated lasers offer significant strategic and operational benefits. They perfectly complement a layered defense strategy, working in conjunction with traditional missiles and guns. crew operations are simplified through familiar, unified interfaces, reducing training burdens and improving efficiency. Critically, these systems complicate adversary planning by undermining swarm tactics and making the use of expendable drones less effective. The economic calculus shifts, making it far less advantageous to launch numerous inexpensive threats against a laser-equipped vessel. Despite their significant advantages, power remains the central limitation for high-energy laser weapons. These systems demand immense electrical output and generate substantial waste heat, requiring sophisticated management solutions. Future ship designs are proactively integrating energy weapons from the outset, moving beyond bolted-on solutions. In these next-generation vessels, sensors, weapons, and power systems are treated as a single, holistic ecosystem, optimized for energy efficiency and operational effectiveness. This forward-thinking approach will unlock the full potential of directed energy. The advancements in naval laser integration reflect a broader trend in modern warfare, the increasing reliance on automation and sensor fusion. This evolution drastically reduces the time between threat perception and kinetic action, a critical capability for confronting emerging threats like hypersonic weapons and autonomous systems. The ship's radar system effectively becomes its nervous system, collecting and distributing vital information at unprecedented speeds. These principles of rapid detection, integrated decision-making, and instantaneous engagement extend beyond lasers, influencing developments in electronic warfare, cyber defenses, and future weapon systems. In an increasingly complex threat environment, speed and integration are rapidly becoming the decisive factors for survival and dominance at sea.